All right, a compound inequality. This is something that, you use it sometimes, but not that often, but it's still something you should know how to do. And you can use it for a couple topics from here. So anyway, so a compound inequality, you wrote these back when we did set notation. For instance, if I want to write, describe this answer area, I would say that x is between, so we always write these like this, because I want to put the largest number on the right and the smallest number on the left. So this kind of does two things for us here. So I want to stay smaller than 10 and bigger than -2. And these things are filled in, so I'm going to put equal bars here. So if you break this up, you have one thing that says x is less than or equal to 10. And then you have another thing that says basically you're going from -2 that way. So, and x is greater than or equal to -2. So realize what's happening here. X is less than or equal to 10. And what's happening is that this part is getting turned around and put over here. So if you were to flip this around, I don't know why you would normally, but if you flipped this around and you put -2 on this side and x on that side, and then you'd have to basically flip the symbol as well. So hopefully you can see that that's what's being done here, and this is just being put to the other side right there to make our whole expression. And so basically, since it's an and statement, so I want both of these things to happen at the same time, that's why I can go ahead and put that there. So, when you see a connected line like that, this is what you write. All right, and that's why the symbols are facing, opening towards the right. These greater than, less than symbols right here. Okay, so x is between -2 and 10. All right, so we're going to graph these things as we do them. So when you're solving an inequality, it's kind of like you're doing two things at once. You're trying to solve, so pretend this wasn't here. If this wasn't here, you'd say, okay, well, I'm going to add 2 to both sides. And then when I get that answer, then I'll get rid of that 3. I'll divide both sides by 3. If this wasn't here, I'd be like, okay, well, I'm going to add 2 everywhere. And then when that's done, I'm going to divide both sides by 3. So what you're going to do in essence is you're going to basically just do them at the same time. You could separate this into 2 separate problems, but why? You're just going to, if you add 2 there, you're going to add 2 there, you're going to add 2 there. So it's like you're solving 2 equations at once. All right, so you're left with 3x, get 9, and over here, 21. And this is going to work out nicely. We're going to divide everything by 3, and everything does divide by 3. I mean, it could be uglier, but what do we get? 3 over here and 7. So I got 7 open, 3 is open, and everything between. All right, this last one over here. Remember, if this wasn't even there, I would say to myself, I want to get rid of the 7, so I had to take away 7, and then I'd have to deal with this whole part right here. So that's our first move. Take away 7, take away 7, take away 7. So get -2. Less than or equal to, there's still a negative x over 2, and I get less than or equal to 3. Okay, all right, so a couple things going to happen here. To get rid of the 2, I want to multiply everything by 2 to get rid of that, right? Because that's the way these 2's cancel out. But if I got rid of the 2, if I actually did a -2, that would cancel out the negatives as well. So I'm going to multiply everything by -2. So times -2, times -2, and times -2. All right, now remember that when you multiply or divide by a negative, these symbols here are going to flip over. Okay, so this is x in the middle, switch them both, gets me a -6, and that gets me a 4. Okay, so technically this is an answer, but notice how it's backwards. We always want to have the smallest number to the largest number, and these symbols need to be facing the other way. It needs to look like this. So we're going to flip it around. We're going to put x, flip our symbols, put the smallest number here and the 4 there. Okay, so then we have a properly written expression. All right, so everything between 4 included and -6 included. All right, there we go. And that is that. Bye-bye.